Okay, these are three amines formulas I have given. You have to write the common name and IUPAC name for these three compounds. Actually, this is one example of aromatic amine. Benzene ring contain NH2 group. When benzene ring contain NH2 group, then it is called phenylamine. Like methylamine, benzene ring is called phenyl. That's why you can write phenylamine, and it has a popular common name. It is also called aniline. In common name it is also called aniline, and aniline is the one of the popular common name. Mostly aniline is used. IUPAC name, if you want to write, here main sign is benzene, na? So benzene plus amine, the name goes to IUPAC name is benzeneamine. Benzeneamine. This is the proper IUPAC name, but nowadays aniline is also considered as IUPAC. So if the IUPAC name asks, if you write aniline, then also you will get the mark. But benzeneamine is the proper IUPAC name. Now this when benzene contains CH2 group, then that group is called benzyl group, and that's why it is called benzylamine. Benzylamine. And when you write the IUPAC name, so numbering should be here 1 carbon, because NH2 is joined with this carbon. That carbon you have to do numbering. This carbon, I mean the ring carbon, don't do numbering, because when you numbering in open chain, you cannot do the numbering in ring carbon. So that's why in numbering you will get 1 carbon, and 1 carbon means it is called methenamine. I mean 1 carbon means methane plus amine, it is called methenamine. And this first carbon, I mean 1 position, contain one your benzene ring. Benzene ring is called phenyl group, and that's why it is called 1 phenyl. 1 phenyl for 1 carbon, it is called methenamine. So the name is 1 phenyl for 1 carbon, it is methenamine. Now this is one example of amine which contain 3 benzene ring inside the nitrogen atom. Benzene ring means all the 3 sides contain carbon. I mean this is one example of tertiary amine. Here 3 phenyl rings are present, that's why it is called triphenylamine. Triphenylamine, because 3 benzene rings are present. And the IUPAC name, when you write, one of the benzene ring you have to consider as main chain. So this is your benzene plus amine, the name will be benzeneamine, and this benzene ring you have to consider as branching. And since they are joined with nitrogen atom, that is why you have to write N, N diphenyl. N, N diphenyl, and the main benzene you have to write as benzeneamine. So its IUPAC name will be N, N diphenyl benzeneamine. So this is about the nomenclature of amines. I think you can write the IUPAC name for amines. Now we will move to the methods of preparation. Methods of preparation of amines. How to prepare the amines in the laboratory. Number 1 method, from haloalkanes, I mean from alkyl halide. Alkyl halide or haloalkanes, both are same. Alkyl halide is the common name, haloalkane is the IUPAC name. What is the general formula of haloalkane? RX. This is one example of haloalkane. I have written general formula. When haloalkane reacts with ammonia, NH3, then it will convert to amine. How? The halogen X will be replaced by the NH2 group, and you will get RNH2. Side product will be HX. One hydrogen combined with halogen to produce HX. HX means like HCl, HBr, H side. So side product you will get hydrogen halide. So this is one example of primary amine, because only one alkyl group is present. But if this primary amine RNH2 If it reacts with again with one haloalkane Rx, then the primary will be converted to secondary one. I mean another hydrogen will be replaced by another alkyl group. So one hydrogen left here, you will get the secondary amine. Again the hydrogen combine with halogen to produce side product hydrogen halide. Similarly, if this secondary amine combine with another haloalkane, then another hydrogen will be replaced and it will convert it to tertiary amine. Again it will release hydrogen halide. So this is one of the method from which we can prepare both primary, secondary and tertiary amine. But to prepare all the Rx, I mean haloalkane, you have to take in huge amount. I mean if you take excess amount of haloalkane, then the reaction will continue like this way and you will get primary, secondary, tertiary. Also you will get quaternary. How? When the tertiary amine reacts with your again haloalkane, then also reaction takes place. This is secondary and this is tertiary. Then also it will react due to presence of lone pair. It will take another alkyl group. Ultimately it will convert to like this. Lone pair will vanish now. Lone pair will form the bond. It become positively charged and X negative will be remain here. And this is called quaternary ammonium halide. Quaternary means 4 degree. So this is one of the method from this haloalkane. You can prepare primary, secondary, tertiary, also the quaternary by adding ammonia. If you take haloalkane in excess amount, then the reaction will continue. You will get the quaternary ammonium halide. So this is one of the method for the preparation of amines. Second method, number 2. By reduction of nitro compounds. Nitro means the NO2 group. When you reduce NO2 group, the NO2 group will convert it to NH2 by removing oxygen. For example, this is one example of nitroalkane. NO2 is called nitro group. Here I have written nitroalkane. If here CH3 is present, then it is called nitromethane, nitroethane, depending on the number of carbon. When you do reduction, this is your symbol of reduction, and reducing as an example lithium aluminium hydride you can use as reducing agent. Then the oxygen will be removed and some hydrogen will be added with the nitrogen. As you know, reduction means addition of hydrogen, removal of oxygen takes place. Ultimately the product you will get RNH2. You will get the amine. And the oxygen combines with hydrogen, it will produce side product water. So this is another method to prepare the amines. Similarly, this is nitrobenzene. If you want to do reduction in presence of lithium aluminium hydride, then also you can convert to amine. I mean it will form aniline. So always you remember, nitro group on reduction convert to amine group. NO2 always convert to NH2 by doing reduction. Now I will give you number 3 method. By reduction of cyanide. Cyanide means the CN compound. Those compound which contain CN functional group, they are called cyanide or nitrile. This is one of the alkyl cyanide. When you do reduction in presence of some reducing agent like lithium aluminium hydride, then the compound will convert it to RCH2NH2. I mean, you will get the amine. How the reaction takes place? As you know, RCN, C and N contain triple bond, na? So when you added hydrogen, when you apply hydrogen in reduction, addition will take place due to presence of triple bond, and the triple bond first time convert to double bond, then it will convert to single bond by adding hydrogen. For example, first time carbon joined with one hydrogen, nitrogen joined with one hydrogen, triple bond is converted to double bond. After that, again hydrogen addition takes place. Carbon will take one hydrogen, then it becomes CH2. Nitrogen will take another hydrogen, it becomes NH2. Double bond is converted to single bond. I mean, this is the product as you have got. So after addition of hydrogen, reduction means nothing. Addition of hydrogen, due to presence of triple bond, directly addition of hydrogen takes place, and the triple bond is converted to single bond. It will convert it to amines. So these are the methods of preparation of amines. Another some methods you will get, like Hoffman reaction and Gabriel reaction, that I will give you in next class. Thank you.